Okay, so tell us who you are.
My name is Paul McPherson. I'm an instructor in the Technology and Applied Design program. Currently I'm teaching the Design and Documentation class, and we do everything from simple modeling to complex assemblies, animation, and as well as home design. And so currently the big project for the class is working to design an energy efficient habitat for humanity home.
Wow. Any potential collaboration on bricks, compressed earth bricks, perhaps?
Potentially. I think each time the class is taught, we're looking for projects to incorporate in, and so it just depends on what project can come along that we can get our students on.
Okay.
So.
And now here we have an injection.
I would just say that you should perhaps definitely talk with Richard about that, because he's the lead on that project.
Richard also on a document, the habitat?
Yep.
Okay.
Yep.
Okay. Let's look at the injection molding machine.
Okay, so this is our plastic injection molder. It's relatively the small scale, just teaching students how to do small prototypes. This is another mold that we have, very similar to the one that you saw earlier. And so students would then slide this mold into the cavity, clamp it down, and then through air pressure and this cylinder, we load the plastic into this container here, into this trough, goes through, and injection molds in, and out comes the keychain.
So powdered plastic, then melted and injected.
Well, the plastic actually comes in small beads,
pellets.
And then we can color it whatever color we want. So through the powder.
Oh wow!
And so then, if you want purple, we just use a purple powder, mix it in, gets into the beads, and that consistency determines what your end product looks like.
What are the advantages and disadvantages compared to a 3D printer?
I would say that you probably have a lot more time in the machining of the mold for this, whereas the 3D printer, as soon as you send the part, it's kind of leave it and forget about it until it's done. However, the 3D printer does take a significant amount of time. We just did a project of 6 parts, the largest part being 2 inches in diameter and about 7 inches tall, and that took about 30 hours to print all 6 parts. So.
And this takes injection process takes how long?
The injection process is a matter of minutes once you have the mold. Setting up the code for the mold can be anywhere between 1 or 2 hours probably, and then making sure that it all aligns. So it may be a little less time, but it's a little bit more involved in getting things prepared.
Once you have the mold and you make a print, make an injection, how many cycles can you get? One every couple of minutes, or?
We can actually, as far as being able to pull this out and do the next mold, you can do a turnaround probably 3 or 4 times a minute. Is how many you would be able to injection off of this machine?
Yeah.
So.
Are you familiar with the Hardness machine back there?
No.
Not at all?
I'm not.
Okay. So there's another machine here. Let's take a look at it. I was told that this is a Rockwell Hardness machine where you basically use this machine to punch into the metal so this is for testing the hardness of metals. You punch it down into the sample that you have, and how far it gets punched down per a certain pressure determines how hard the metal is. And you've got a little point that gets punched in, like a tiny little point. And here's another one with a harder point, so for different kinds of metals. Okay, so this is a nice candy store for all kinds of fabrication.
The other machine that I would mention is we do have a small vacuum forming machine, and that's one of the things that we have looked at of possibly making bigger or getting a bigger machine to do.
Show me the vacuum forming.
So again, this is more of a prototyping machine, and so we can do, I think it's a 14 by 10 mold, and so we would put the pattern on this base here, and then we clamp the plastic into the center, and drop it down. This oven comes up and heats the plastic up. And once the plastic is heated and ready to be formed, we can press this down over top of the mold, and just by clamping down these two handles, it turns the vacuum on and will form around the mold.
So what do you do with this? Like this?
Sorry.
This would be an example mold that would fit onto
You
that.
have a mold in there?
Yes.
The point of the vacuum is to get all the air bubbles?
It pulls this.
It pulls the heated plastic down around this mold.
And it becomes a 3D?
Then you have a shell. So you end up with a plastic shell. So this, when you pull the plastic down...
so that actually sits on here.
Uh-huh.
You're drawing a vacuum when you clamp it down.
Oh, okay, so that's your mold, and you just get three?
Yeah, so...
Oh, so this is just the mold?
Yes.
Yes.
That is
okay.
Yeah, so this would sit on here, clamp down.
So this is your plastic that you're pulling down over something.
Yeah.
That's right. And so we put our pattern in here, and then once the plastic is heated up, it'll kind of become wavy and then stretch back out, and then we can vacuum form around that.
And the molds are made of what?
It can be made of anything, really. Wood, plastic, wax. So
anything that...
Yeah.
The temperatures involved are not very high. I think actually Flatboys, to Phlatvboyz, a couple of, it's a husband and wife team who do open source CNC foam cutters and things for model aircraft assembly. They actually have a small open source vacuum former.
Oh.
It's a shop vac, and I think they use the heating element from some kind of toaster at Walmart.
Yeah. Oh, interesting.
So this is not a complex machine, and I know there are open versions of it that already exist.
And the other one you mentioned that's open is a foam cutting with a wire, or
no,
how?
they use a rotary bit.
Rotary bit foam cutting.
It's an MDF construction. The plans are open. You can order a kit from them if you want.
MDF?
Yep.
What's MDF?
What does MDF stand for? Medium density fiber board, I think.
Uh-huh.
And its point being is the machine can cut up to, I had one actually for building small aircraft, and it'll do about a 30 to 32 inch wide piece of foam, arbitrary length. So there's basically a clamp down, you have a roller, and so your y-axis is it rolls the foam back and forth, your x-axis is here, it has minimal z travel on the head, it's basically a Dremel on a carriage, and you can cut arbitrary shapes out of insulation foam like you might use for putting on a home, that's one, or even that's stuff from the dollar store, and so thinner foam. And it's all, their intended use for it was for cutting out model aircraft.
So car bodies, aircraft bodies,
yeah,
fiber, basically like some kind of a fiber resin body.
I don't know if I'd do anything that heavy. They literally like insulation foam.
Right, insulation foam to make the forms for whatever you do after
right,
that.
Right.
Yeah.
And in our case, we were cutting wings, fuselage, wing
About
ribs.
Sounds like wind turbine blades.
You could, although because it clamps down, you'd have to do a bit of a jig, just so that way your clamp stayed firm. While you'd have to cut the wing out of a negative. You basically had to cut the wing out and make sure that you still had enough clamping force on that particular machine, because you brought a clamping bar down on your material, so you couldn't end up where you had a blade, like your airfoil, you wouldn't want to be clamping on a single point on that airfoil. I don't know that it would be great for that kind of work.
Okay.
So
we'll see.
Anyway,
we'll look at that online.
Yeah.